I forgot to start the recording when I started explaining this, but so far we've always talked about is that the exponential function y equals e to the x and the natural logarithmic function ln of x are inverse functions of each other. As we move forward, we need to be reminded of the operations within exponential functions. Remember that when you are multiplying with exponents, you add the exponents, and when you're dividing with exponents, you subtract the exponents. There are properties of natural exponential functions. You need to remember that your domain, which means what x's can you plug in? You can plug in any x value that you want from negative infinity to positive infinity, but the range, which is your y value, will always be greater than 0. And you can see here in this red graph that the y values are always greater than 0. It gets really, really close to 0, but it never goes past that. Your function, this red function, the e to the x, is always continuous, it's always increasing, and it's a one-to-one. The graph of the natural exponential function is always concave up during the entire domain. And the limit of your function as it approaches negative infinity is continually getting closer and closer to 0. If you don't get those properties written down, it is totally okay. I'm going to save this document as a PDF, and I will upload this entire document to Canvas once we finish this meeting. Are there any questions so far? Okay, So let's start off by looking at the derivative of our function. If you have any number, a, to the x power, and you want to find the derivative of this, it is always a to the x times the natural log of whatever that number is. So if you had e to the x, the derivative of that would be e to the x times the natural log of e. Now, what does the natural log of e equal? I don't know if any of you remember, but if you want to take a second, get your calculator out and put in the ln of e. The ln of e is equal to 1. So 1 times the e of x is the e of x. Y equals e to the x, the derivative is e to the x. This is the coolest function because it is the only function that has its original function as its derivative. I'm going to turn my computer around and you guys tell me if you cannot hear me. It's going to make it a lot easier for me to write on it. All right, so let's look at an example. Y equals e to the negative x squared. So we're going to take the derivative of this. Remember that the derivative of e to the x is e to the x. So the derivative here is going to be e to the negative x squared. Now we also have to take the derivative of the inside function, just like chain rule. So if we're taking the derivative of negative x squared, that's going to be negative 2x. And then if we simplify that, it's just negative 2x e to the negative x squared. Second example, x squared times e to the negative x. Here you have a function times a function, so it's going to be product rule. So you may want to break this down to label this as your u and your v. So the derivative of the first, the derivative of your u would be 2x times your v plus your first function times the derivative of the second function. So the derivative of e to the negative x is going to be e to the negative x, and then the derivative of negative x is negative 1. So this becomes 2x e to the negative x. Negative 1 times all of this would be negative x squared e to the negative x. And then if you wanted to simplify further, you can take out a greatest common factor. So we could take out an x and an e to the negative x, which leaves me 2 minus x on the inside. Example number 3, y equals 5e to the x squared plus 5. Now, x squared plus 5 is all in the exponent. So when we go to do the derivative, 5 is just a constant in front of your function, so you're going to bring that 5 down. The derivative of e to the x is e to the x, so it's going to be e to the x squared plus 5, and then times the derivative of this exponent, which is 2x. When you simplify here, 2x times 5 is 10x. Any questions?
Nope.
Please stop me if you have any questions. All right, next we're going to put today's lesson with what we talked about last week. If you're looking at the, what is the derivative of y equals the natural log of 1 plus e to the x divided by 1 minus e to the x, think about our rules that we just talked about at the beginning. When you are dividing, you are subtracting. Well, exponential functions and logarithmic functions are inverses of each other. So here we're dividing, so to expand this out, we can rewrite this as a division problem. So it'll be the ln of 1 plus e to the x minus the ln of 1 minus e to the x. Now, last week, remember or it might have been the week before last, when we took the derivative of the natural logarithmic function. When you take the derivative of that, it's 1 over that function times the derivative of the inside. Well, the derivative of 1 plus e to the x, the derivative of 1 is 0. The derivative of e to the x is e to the x. Okay, minus the derivative of this ln would be 1 over 1 minus e to the x. The derivative of 1 is 0. The derivative of negative e to the x would just be negative e to the x. So your denominator here is 1 plus e to the x in the top, minus 1 minus e to the x, and a negative, I think you can agree, makes a positive, and that would be e to the x in the top. You cannot combine these two because the denominators are not the same. I would leave them here, and I would not reduce any further. The next example is the square root of x plus e to the x times the ln of x. The derivative here. First, before you start taking the derivative, you want to rewrite this, x to the 1/2. You're going to be able to take the derivative of x to the 1/2 like you've always taken a derivative. And then when you do this right here, this is going to be product rule, because that is a function times a function. So the derivative of x to the 1/2 is going to be 1/2 x to the negative 1/2, because we bring this down in front, and then 1/2 minus 1 would be negative 1/2. Now, for the e to the x ln of x, the derivative of the first is e to the x times the second plus the first times the derivative of the second. The derivative of ln of x is 1 over x. Now, I would simplify this. You have 1/2. Let's keep that x to the negative 1/2 plus e to the x ln of x plus e to the x over x. Now, in this case, we're going to keep going, and we're going to find the second derivative. So the second derivative is negative 1/2 times positive 1/2, which will be negative 1/4. X, negative 1/2 minus 1 would give you negative 3/2. Product rule again. So the derivative of the first is e to the x times the second plus the first times the derivative of the second. And then guess what you're going to have to do here? Quotient rule. So quotient rule says low d high minus high d low over low squared. So you have low d high, the derivative of e to the x is e to the x, minus high d low, the derivative of x is 1, all over low squared. I'm not really sure how much more you can reduce this. If you wanted to clean it up a little bit, it would just be negative 1 over 4. You could do x to the 3/2 in the denominator here, plus e to the x ln of x, plus e to the x divided by x, plus x e to the x minus e to the x over x squared. There's really not a whole lot you can do there. You can leave it like that. All right, then nobody's saying anything, so I'm going to keep going. The next example is y equals e to the 2x times the tan of 2x. We got a little bit going on here. We've got product rule, and then we've got chain rules inside of that. So if you want to take a minute and get out your formula sheet with your pink formula sheet with your integration rules on it, so you can see what, and derivative rules, so you can see what the derivative of tangent x is. We're going to have to do a product rule. So the derivative of the first, the derivative of e to the 2x is e to the 2x times the derivative of this exponent, which is 2, times the second function plus the first times the derivative of the second. Now the derivative of tan is secant, and remember, leave your inside in there, then times the derivative of that inside. So the derivative of 2x is 2. Then I would clean this up. This is going to be 2e to the 2x tan of 2x plus 2e to the 2x secant 2x. I think we can all agree that our GCF here is 2e to the 2x, which leaves you with tan 2x plus the secant 2x. Are there any questions so far? All right. I am getting ready to start the integration now of exponentials and logarithmic functions. So our first example here, this is where we're switching from derivatives to integration. Now this is going to be pretty simple because if you remember, the original function is e to the x, so the derivative is e to the x. So if the derivative is e to the x, then the original function is e to the x. So it's going to be pretty simple here. Whenever you go back and forth, the answer is always e to the x. So that's why it's almost like they saved the best lesson for last, because this is the easiest one. I love it. So our example here is e to the negative x to the fourth times negative 4x cubed. You're going to look at some u du substitution. So if my u is negative 4x cubed, then the derivative would be negative 12. No, hold on. Miss McClure is doing this all backwards, and I will have you all totally confused. The u is negative x to the fourth. The derivative is negative 4x cubed dx. So you can see how this all lines up. This is my u, and this is my du. So this becomes the integral of e to the u du. Well, you know that the integral of e to the x dx equals e to the x plus c. Pretty simple. So if we're doing the integration of e to the u, it's e to the u plus c, and then you can back solve your u in there. Okay, the next example is e to the 1 minus 3x times the dx. So my u is always my exponent, whatever the exponent is for your e, that is always your u. So this is 1 minus 3x. The derivative here is negative 3 dx. Well, as you can see, your negative 3 in front of the dx is missing. So divide by negative 3 on the outside. You have negative 1/3 times the integral of e to the u, and then negative 3x dx is your du. So negative 1/3 e to the u plus c, and then let's plug in our u. So e to the u is 1 minus 3x, and then we're going to add our c. The next example is e to the x times e to the x plus 1 squared dx. So my u, I'm going to use what's inside this parenthesis here, e to the x plus 1. Okay, what is the derivative of that? E to the x dx. Well, e to the x dx matches your du. Let's color code it here. So this becomes u squared du. So think about how we integrate. Well, when we integrate, we always add 1. So 2 plus 1 is 3, and divide by that number. So then you plug in for your u, so that's going to be e to the x plus 1 to the 3rd power divided by 3 plus c. If you're unsure, you can always take the derivative of this and see if you come back with your original. So if this was 1/3 times e to the x plus 1 cubed plus c, and we want to derive this, 3 times 1/3 would be 1, e to the x plus 1 to the second power, and then take the derivative of the inside. Well, the derivative of e to the x plus 1 would be e to the x, and the derivative of c is 0. And so I think you can all agree that we came back with our original function. Now, that is all there is to the derivative and integrals of natural logarithmic functions. I'll take any questions if you have any. No one has any questions?
No, ma'am.
Okay. Well, I will post this. I'll post this to Canvas. It does take some time for the video to convert. It'll be probably tomorrow, honestly, before it loads up into the iCloud, and then I can convert it over to Canvas. But you guys have seen it, and I'll also post these notes. You will see that I put the due date for this quiz for next, let me look, because I don't want to tell you a story. All right, so I put the due date for this quiz for April the 14th. So that's going to give you a long time, 2 weeks to work on it. You're not going to need 2 weeks, but I'm going to open anything. I would go ahead and get this quiz done, and then if you have any questions, you can ask me on Wednesday. You're not required to attend the Zoom meeting on Wednesday. The only thing I'm going to do in the Zoom session on Wednesday of this week is do any kind of Q&A, any kind of questions you don't understand about the quiz. And then you will officially have a spring break. Nothing due for me after that. I just left the quiz open for anyone that had any questions. And then the following Wednesday that we will meet will be the 15th. That will also be Q&A. And then that you'll be getting ready for your Chapter 5 test, which will be your last test. So this is your last quiz in calculus. Please reach out to me and let me know if you have any questions. You can always reach me by email if you need me. Well, if y'all don't have any questions, that's all I have for today.
Okay.
All right. Bye, guys.
Have a good day.
Bye.
Bye.